Hello Bellevue College. Today we will be doing the Beers Law experiment. So to begin, we're going to start by making our stock solution that we will later dilute in the lab. So in your pre-lab, you were supposed to calculate the amount of Allura Red, also known as red dye 40, that you need in your stock solution. And so we're going to go through the math quick. And so your solution is supposed to be 1.9 times 10 to the negative 4th molar. And it states in there that the molecular weight of Allura Red is 496.42 grams per mole. So you'll take your molarity times it by the amount of, or the molecular weight, and then this is for a 500 milliliter solution, so that equals half a liter. So as you'll see here, the moles cancel out here and the liters cancel out there, leaving us with grams. And you should get a number that is around this one. So in this case, since I'm the only one doing the lab, I'm going to be making half of that for the solution. And so I'm making 250 milliliters. So with that same math equation, we are going to be going for more towards this amount of grams that I'm about to measure out. And so I'll also go through the calculation of the molarity towards the end. So we can do that together, and then we'll all have the same molarity in our post lab. All right, so now we have our balance. And we have it zeroed out with our weigh paper. And remember, we're going for 0.0235 grams, or in this case, since there's only 3 decimal places, we're going for 0.02, around 234. So, just want a very small amount here. Open the door. Come on. Looks like we need a little bit more. Oh, well, there you go. Alright, so now that we have 0.024, you want to write that down. And since, like I said before, we're doing less of our stock solution, we'll go through the calculation together. So, write down that number, and then we will move on to making our stock solution and go from there. Alright, so now we're back at the bench. So to make our stock solution, we are going to, so I have a 250 milliliter volumetric flask and a brain part there. So we're going to start by adding a little bit of distilled water, so it's easier for this solid to dissolve. So add some. Then we can take our funnel. Make sure it's easy for the powder to get in. So then we have our powder from the balance. Pour that in. Put some water down it. So a little bit better. Trying to make sure we get all of that in there. Even though it's kind of not the easiest. Okay. Rinse off the funnel. Put some spots on the outside. Okay. I'm going to go over the distilled water. See, I filled it up pretty full, but we're gonna do the rest this way. So you're gonna wanna fill. So we're getting close to the line. So we'll just do very slowly. So ideally you want, when we do all of these, we want the meniscus just to be touching the line. Like here. Sorry, can't hold it still. As you can see, it is there. So then we are going to swirl our solution a little bit just to make sure that it's all mixed together. Tipping it. Look how unfocused the camera is. There we go. Now we've completed our stock solution. Okay, so now we have 4 100 milliliter graduated cylinders, and then a beaker of our stock solution. And then we have a 10 milliliter graduated pipette on a pipette, what is this? Pipetter, I guess. So for time's sake and not to bore you, I'm going to go through making one of these completely, tell you the volumes of the other 4, and then I'm going to make them myself, not on camera. So for the first solution, we are going to, solution number 1, we are going to measure out 5 milliliters of our stock solution and then fill the rest with water. And then solution 2 will have 10, 315 of our stock, and 420 of our stock. So to start, we'll insert our pipette. So now that can't really see this, but the meniscus is on the 5. So I'm gonna go ahead and get rid of it into our grad cylinder. A little bit of room for calibration. And if you noticed, I put a little bit of water in the bottom of the cylinder, just after I rinsed it out once to make sure it was clean of any other residue. So then we're at that. And we're going to continue to add water, quicken the process. There's my funnel. I'm going to dump some. Till we get back to the neck. Get it all the way up to the line. So yeah, we're at the meniscus. I'm going to take a stopper and do what we did with the stock. Just mix it up a little bit. So that's how we're going to make our dilutions. So I'm going to go ahead and do 2, 3, and 4. Like I said, 2 is going to have 10 milliliters, 3, 15 milliliters of our stock, and 4 is 20 milliliters of our stock. And then after those are done, we're going to go over to our colorimeter and make our calibration curve so we can find the concentration of the end. Okay, as promised, I'm going to walk you through calculating the molarity of the stock solution, and then I'll let you go ahead and calculate the molarity of the 4 dilutions before we move on. So we had, since I did less volume, this was the number of grams of Allura Red we had. So we are going to try and find, so we have that, and then we made 250 milliliters of it. So we will start with the grams. We'll call it Allura Red. And so we know that the molecular weight of Allura Red is 496. You want that on the bottom. 42. So we want our grams to cancel out, a mole on the top. And then we want moles per liter. So we're going to divide by 0.25 liters, because that's how much solution we made. So let's see how close we were. I get 0.0001932 moles per liter. So that, if we write that in scientific notation, 1.93 times 10 to the negative fourth molar. So then you're going to use that value to find the molarity of the 4 dilutions. So I'll let you do that, and then we will move on to the calorimeter. Alright, so now that we have our 4 diluted solutions, you can kind of see that they get slightly darker as they move on. So we have right here is 1, 2, 3, and 4. So we're going to measure the absorbance of each of these. So we have the lab open on Vernier. So you can see that we're going to be measuring the absorbance against the concentration, which is on the bottom. I know that the font is pretty small, but moles per liter. So we are going to start by calibrating, and then we'll move on. So for this whole experiment, we're going to use 1 cuvette, and we're doing that so things are more accurate. So grab a CHEM wipe, wiping again. So we have clear side, which that's where the light's going to shine through, and then the rigid side. So just wipe it in general. We're going to calibrate this with distilled water. So I'm just going to start by filling the cuvette about like 3/4 of the way full, just so the light can go through the sample. And so we have the colorimeter set at 470 nanometers, and that's around the wavelength that Allura Red absorbs at. I can open this. So just set it in there, and then, okay, so there's a button. It says cal. I'm just gonna hit that. The light's gonna blink, and when it is done, it's calibrated. And look, it's at 0. So we're going to remove our cuvette. Your pipette. Solution number 1. Now you can't see anything I'm doing. We'll just go over here. Just swish it around. Alright, now that we've rinsed it twice with the solution we're using, we will fill it up 3/4 of the way. Alright, cap it, move our solution out of the way. Wipe it. Okay, so since it's not ever going to be stable, we are going to go with something that's in the middle. So I would say 0.117 as your first absorbance. So write that down. I'm not going to make the graph since you're supposed to calculate the concentrations. So you can take down the absorbances, and then eventually you'll want to graph the absorbance versus the concentration you calculated for each dilution. And that is something you'll have to turn in. So once that one is done, move on to the second one. Okay, now we have solution 2 filled into our cuvette after it's been rinsed. And we are going to put it back into our colorimeter this way. Close it. Just wait for it to stabilize. Maybe, yeah, 0.232. But you use your best judgment. So choose, write it down in your notebook for solution 2. We'll move on to solution 3. Ta-da! Solution 3. Just like before, do the rinse and fill. Get it all filled up. Wipe it down. Open. Alright, looks like we're 3.41. Look how stable it was for a second. 3.41. That's what I would pick. So you choose. I'll let it jump around a little bit. Make your best guess. So that's solution number 3 with the 15 milliliters of stock solution in it. Move on to solution 4, our darkest. 20 milliliters of stock. Gotta fill the solution 4. Wiping it down. Put it in. 0.43. Ooh, 6 or 7 might be a good answer. I'll let you choose again. Then we'll move on to our unknown. Alright, so I rinsed with the unknown solution in our cuvette 2 times, filled it up, and now it is in the colorimeter, and we are looking at a very jumpy number. I think 2.077 is the most reliable number. Seems to sit there the longest. So I would go for that absorbance for the unknown. And that's all, folks.